Meet the weird cousin of a black hole, a black ring. Scientists believe these mysterious rings could exist in a universe with 5 or more dimensions. Now, a new study of 5-dimensional black holes has provided an insight into how these objects could evolve with gravity so intense the laws of physics break down. The research claims that, should this type of black hole form, it would lead to the appearance of something known as a naked singularity, and could ultimately break Einstein's theory of relativity. Stephen Hawking once said that nature abhors a naked singularity, because it would throw out everything we think we know about the universe. No one has ever found evidence of a naked singularity, but the latest research suggests that they could exist. The researchers, from the University of Cambridge and Queen Mary University of London, have simulated a black hole shaped like a very thin ring using computer models. The ring gives rise to a series of bulges connected by strings that become thinner over time. These strings eventually become so thin that they pinch off into a series of miniature black holes, similar to how a thin stream of water from a tap breaks up into droplets. Ring-shaped black holes were discovered by theoretical physicists in 2002, but this is the first time that their dynamics have been successfully simulated using supercomputers. This would cause the equations behind general relativity to break down. General relativity underpins our understanding of gravity, everything from the age of the stars in the universe, to the GPS signals we use to find out way around, is based on Einstein's equations. In part, the theory tells us that matter warps its surrounding space-time, and what we call gravity is the effect of that warp. A singularity is a point where gravity is so intense that space, time, and the laws of physics break down. General relativity predicts that singularities exist at the center of black holes, and that they are surrounded by an event horizon. This is the point of no return, where the gravitational pull becomes so strong that escape is impossible, meaning that they cannot be observed from the outside. As long as singularities stay hidden behind an event horizon, they do not cause trouble and general relativity holds. The cosmic censorship conjecture says that this is always the case, said study co-author Marcus Coens, a PhD student at Cambridge's Department of Applied Mathematics and Theoretical Physics, DAMP. As long as the cosmic censorship conjecture is valid, we can safely predict the future outside of black holes. Because ultimately, what we're trying to do in physics is to predict the future given knowledge about the state of the universe now. But what if a singularity existed outside of an event horizon? If it did, not only would it be visible from the outside, but it would represent an object that has collapsed to an infinite density, and no one knows what would happen to objects at this point. Theoretical physicists have suggested that such a thing, called a naked singularity, might exist in higher dimensions. If general relativity breaks down, it would throw everything upside down, said co-author Sarantunya Suvyunakul, also a PhD student from DAMP. It would no longer have any predictive power, it could no longer be considered as a standalone theory to explain the universe. If Einstein is proven wrong, an alternative way of explaining the universe would then need to be found.